So thank you everyone for being here with us, and thank you for the panelists for forming such a great group, and I'm very looking forward to our discussion. So as we start, I would love you to give a quick round of, can you hear me there? Yeah, of self-introductions, please. So maybe we can start with you, Jayson, and then...
Yes, my name is Jayson Dunn. I'm a business development manager for artificial intelligence for state and local government with NVIDIA. I've been with NVIDIA just a short while, but prior to this role, I was the chief information officer for the city of Cincinnati in Ohio. So a definite background in local government and in the application of some of these smart city solutions.
Hi, my name is Matthew Mercado. I'm the CEO and co-founder of Magma. We are a real estate platform using digital twins, blockchain, and AI to enhance building operation.
Cool. I'm Tony Garcia. I'm an architect and urban planner. I'm based here in Miami. I'm a UM grad from the School of Architecture, and we practice transportation planning and engineering and do something called tactical urbanism that we're going to talk about in a second.
This for you. I'm Victor Dover. I'm a town planner and urban designer. Our firm is called Dover, Kohl & Partners. We're located here in Coral Gables. Like Tony, I'm a UM grad. We have a bunch of folks that came through the university working in our firm. And we help communities figure out what they want to be when they grow up by drawing lines on maps, working for private real estate developers and local governments and community groups. We usually introduce ourselves as urban designers and then explain what that means, which is troublemaker question askers.
Hello, my name is Fredrik. I'm the co-founder of OnePrint. We're a construction 3D printing company, or concrete 3D printing. So we work with large-scale construction 3D printing of infrastructure and sustainable and resilient housing. We have an IP from University of Miami that is called Sea Hives, which is a coastal protection system that we're scaling up and doing a commercialization now together with Titan America and a Department of Defense grant. But we're also working on housing projects. So we have a large Section 8 workforce housing project on 2-floor with concrete 3D printing coming here in a couple of months.
Thank you. So I would like to start with a round of questions for each of you, and then we can start discussion, okay? So Jayson, when we think about smart cities, we think about a vast amount of data, right? And I would like to hear from you, like how NVIDIA works, like the private sector working with the government on how to deal with that amount of data.
Yeah, that's a really good question. When you think about how governments traditionally use data, we're usually creating it, processing it, storing it, and retrieving it in enterprise applications. But in the future, we're not just going to be retrieving data from applications. It's going to be more synthetic when sensors are adopted. And when you think about digital twins and the various AI models, we're on the precipice of massive amounts of data. That was one of the highlights of our CEO's keynote at our GTC event this year. We're anticipating in the very near future, when you think about how a lot of these solutions are going to start being deployed, likely generating more data in 1 year than we've generated in the last 500 when we start ingesting it in real time. And so NVIDIA is helping agencies process this data at the speed of light and start turning that data into wisdom that an agency can use. So agentic AI, where you've now got service delivery companions that can process and see something happening in a digital twin in real time and then act on behalf of a service delivery provider. Or the digital twins that are now coming, and also the edge computing, where now you can process and make decisions where the data is being ingested, as opposed to it moving and traversing a network. So there's a lot of opportunities with this data, and it made me think about the question that we had on the last panel that we were just talking about why cities are a certain way and why we can't do things. We're looking at redesigning cities, not just designing them. And so a lot of these environments were built in a different time for a different purpose. And so now having that data and that processing power to be able to see how things can work better in real time, that really is the start of using technology to help with some of those redesign concepts.
All right, thank you. So, Matthew, so you work on, collecting a lot of data and enabling that collection with, core network systems. And I'd like to ask you, how this approach can empower, more affordable and scalable collectivity solutions, for collecting that data and connecting the city.
Right. So we believe that we are at a turning point where really technology can be really used for the benefit of all in cities, and as part of that, digital twins and blockchain, we call it digital assets, can be a real trigger to transform the way we manage cities and buildings. So collecting data is one thing, but then assembling data to make it insightful and actionable is something else. Data is everywhere. Raw data is a commodity. It's everywhere. It doesn't have a meaning if we don't construct it in a meaningful way. So it's going to be about creating digital assets, using those digital tools so we can apply action and make contracts. Because having data is about creating value that you can share and exchange. That's how you make a contract. The parties of a contract, there is value exchange, and when you put data together, you can execute that contract. So in a building environment, you have a lot of systems and a lot of parties that use different qualification and different systems that don't communicate with one another. So making them interoperable is going to be the key, and making them communicate with one another is going to create value. So what we believe is that we have to redefine value and redistribute it so it can bring insight to tenants, service providers, cities, and citizens. So that's the challenge that we have today. It's together, public, private, and academia must sit around the table, and the same way we built the physical world, now we have to build the digital world. This infrastructure has to be collectively built and thought so we can redistribute value between everyone.
All right, so Tony, just following the sequence here. So your company, Street Plans, focus on strategic urbanism, right? And then tactical and rapid implementation of improvements. So how do you think the private sector can contribute to creating more agile and responsive smart city interventions, and how this intervention could be scaled up?
Sure. So it's really funny the way that this worked, because we sat down, we were not told to sit in this order, but this is the collection of data, the creation of a digital environment to interpret that data, the application of that data in the real world. And I don't know where we're going with this, but there is a pattern here. Yeah. So I love that was set up. In our work, what we do is, we plan streets and neighborhoods, and I mean, speaking for both of us in a way, plan these places, and then we go out and prototype them in a very analogous way to the way that the technology world works. We prototype things very quickly and with inexpensive materials to try to see if it works or not, to fail forward, right? I think what we bring to this conversation is grounding this trajectory back down to the human scale. I'm going to speak for you also to say that
you're doing great. We
are humanists. We believe in centering the human being in the design of our cities. And I would challenge you, Jayson, that we're not redesigning cities at all. We should not be. We have a good template for how cities work successfully. We stick to that template and then have the technology work for us, versus try to adapt the way that we have in the last 100 years around the car, which was a technology of its time. We kind of destroyed our cities adapting to that technology. And I don't want to see that happen again. I don't want to steal your thunder if any of this is going to happen again. But
don't be too early. You're doing great.
Yeah. Okay. And then I lost my train of thought. I think I'm going to leave it there. We like to take the data. That's where I was going with this. When we're doing our tests in the real world, using, like, say, we'll go out and build a bike lane somewhere. Temporary, a month, a year, whatever it is. The way that the technology works for us is seeing how our interventions actually impact people's travel behavior, rather than try to guess at it. Because as architects, engineers, planners, we make a lot of this stuff up. We don't know that it's going to work ahead of time. So having the data from a sensor that will tell us, well, you built that bike lane, but it didn't quite work the way that you wanted it to work, that's useful to us. And then we can redesign that bike lane so that it works for people actually in the real world. And that's how we would use that in the private sector, in our practice.
Thank you. And I think the sequence is working really well, because I will ask you about, how you take the human-centered perspective when planning the city. So you leverage on everything that they are saying, and then you are planning towns. How do you take this approach of human-centered to increase, walkability, as we mentioned, it was asked in the previous panel, for example.
I was, throughout the afternoon, I was thinking instruments and technology, the purpose of it is to take something that's hard to do and make it easier for us to do more well. That's what it's for. And the city itself is an amazing technological invention. And you might have forgotten what it was invented for. Anybody want to guess? It was invented to minimize the need for transportation. The city is a concentration, like a deliberate concentration, that makes it possible to do things close together. This is my chance to shout out to Professor Costa. Thank you for every single syllable of your address this afternoon, because that was very inspiring and spot on. We got confused, and I think Tony alluded to this, in the 20th century, and started to think that the purpose of the city was to make it easier for you to move great distances every day, not necessarily for any particularly good reason. And so, and part of that is fueled on by poor instruments. I spend about half my day in some way or another interacting with technology to make something that used to be hard to do easier to do, like make a beautiful drawing or compare the layout of the streets to the detailed information we now get about the topography, for example, or the movement of water across a site, or that kind of thing. But I'm also spend the other half of my day trying to blunt the bad impact of crude technology introduced in traffic engineering. Technology that will fool you if you don't dig deep enough into thinking you need more parking than you actually need, into making you think that wider and faster roads are better roads, instead of thinking that safer ones are better roads, more beautiful ones and more valuable ones are better roads. So the systems that are being used in the private sector, which is kind of the origin of your question, for transportation engineering have not caught up with the reality of human life and the goal of what a city is really for, which is to make it more convenient, not less. The addiction to the car, Professor Costa called it, I would say it's probably beyond that, more like slavery at this point, because if you thought that the purpose of getting behind the wheel was to give yourself liberty to go wherever you want, whenever you want, as it turns out, A, that's not as convenient as you thought. You may be spending a bunch of time stuck in traffic and a bunch of energy and money that could be going into other things, including housing, which is very expensive. And B, for a lot of people who can't drive or for a reason or another choose not to drive, including people whose age or ability don't allow them to do it, building our city around the assumption that every trip is a car trip every time enslaves them and limits their liberty to just the areas they can reach within walking distance or through meagerly provided public transit. So then that second half of my day, I'm also pointing out the flaws in that analysis and saying we need better information. And so the data sets, Professor Wang, your information from the U of F, so incredibly valuable. The data sets actually could liberate us a bit into showing what is really happening instead of what the old traffic model predicted. And a great example of that is at work here in Miami-Dade and in Broward County. Our friends at Marlin Engineering have an amazing AI tool they use to analyze time-lapse video footage of pedestrians faced with no other alternative crossing in the middle of the block. That is, not crossing at a safe, signalized intersection, but crossing a big, wide, and dangerous road, the only place they can, which is in the middle and running for their lives. That technology has revealed to our local governments just how dangerous some of the street corridors actually are, because instead of just recording the actual collisions that result in a fatality or hospitalization, they now can illustrate the near misses. And so to me, that kind of technology might just get us out of the predicament the crude technology got us in. Cities are for moving less, not more.
Thank you. So, and after all this planning, we come for, prototyping and manufacturing a lot of these installations. Yeah, so how do you see, this rapid prototyping and manufacturing contributing for smart cities and this relationship between the private sector and the government?
Right. So I said we work with 3D printing, and 3D printing was invented to do rapid prototyping. It started with plastic and steel and so on, and now even concrete 3D printing. And it's creating a lot of new type of products. So we work within two sectors, which is resilient infrastructure, green-gray infrastructure, resilient sustainable housing. So when it comes to infrastructure, our slogan is breaking the mold. So what does that mean? Today we have precast factories that are large. You have to buy steel molds that you're pouring concrete in. You're very limited to your molds. But with digital construction, what we are doing, we can rapidly prototype. We do that a lot for infrastructure projects, for different kind of stakeholder, AECOM and big engineering firm. They say, oh, we have a product here that might be interesting. We can go from a napkin sketch to a prototype, and then we can go into engineering after that to see if it's working. So that means that we can do a lot of new type of infrastructure products for the cities. If you take that into residential and commercial construction, we are now just to backlog there, we will be able to store much more data when we're having those digital files rather than storing molds. We store our digital files and we can pack them with data, what kind of material, engineering, and so on. So we can rapidly scale, also open up small factories that are fast to manufacture, meaning with 3 people we can open a small factory that can come up with custom solution for cities or and so on. When it comes to residential and commercial housing, we're working on our first project now, and 3D printing is basically BIM modeling is made for 3D printing. So our goal is to use BIM already from the design into the architecture, into the engineering, into the manufacturing, but also load it with all the data from different kind of performance material that we're using. So we're using carbon capture material from a company named Carbon Limit. They also have a product called Kohlcrete, so it can save on energy consumption. We use different kind of surface texture from text code that can lower the surface texture of the house, and then we can pack all this data into a digital twin, hopefully, that can be developed and that can be handed over to the new homeowner, with intention to lower the insurance and so on, lower their energy cost. So where we fit in all of this is that we are working on faster, more efficient construction of infrastructure and housing, and how we can connect this into new type of cities and smarter cities.
So from what you're saying, I understand that we are not only collecting data from government-led infrastructure, but also residential, and that leads to a huge and increased amount of data that can feed back to the system. For example, I can know in advance how much that house will consume in terms of energy, and depending on the weather predicted for that week, let's imagine, put that way. So, so going back to you, Jayson, how do you see, like, for example, NVIDIA working in partnership or any kind of project successful that you could share on how to both deal with all this data and how to support collecting this data, because you need devices integrated in every piece of the construction.
Yeah, the biggest thing that we do is we work very well with our partner ecosystem. We work across all levels of government on enablement activities, training, AI labs, just a number of things just to bring that thought leadership as well as the product knowledge and that subject matter expertise to our customers. That's really the best way that we help. We signed workforce development MOUs with a number of states across the country, and we try to work well with our partners to get some of those visions to realities on behalf of the customers. For example, the state of California, Caltrans, their State Department of Transportation, helping them with our partners develop a digital twin of the entire highway system. Then you think about kind of to the point you made, Tony, about redesigning. It was a really good call out. Maybe redesigning is too strong of a word, but how do you know what needs to be done on your highway system without knowing what's happening on it in real time? And so all of those decisions really require data and visibility. We're not going to redesign an interstate, but you can make some decisions on how to change certain things. So things like that. Also, Amarillo, Texas, for example, 24% of the population is non-English speaking. So working with our partners, using our technology to help them implement a digital assistant named Emma to help with translating in over 100 different languages the different services that the city delivers. So there's a lot of things that we're doing to try to help with adoption and flatten that adoption curve. Something Professor Yang brought out in her lecture that I thought was really interesting. The technology uplift is intense for cities and counties at times. And there are a lot of things that are cost prohibitive. And so these projects have to have near-term ROI, but they're generally funded across multiple administrations. So just the value proposition is where we're seeing a lot of agencies struggle. So we try to help with that. We try to share the stories, just like the Coral Gables team, what they've been able to do, helping get things implemented so that they can scale, because what we're finding is most cities and counties, and states for that matter, have very common problems. So if you can solve it one way in one agency, then you can flatten the curve of adoption for others in the future.
Thank you. So Matthew, I think that leads to you as well, like when you were saying that the importance of translating all that information in more feasible ways to understanding and supporting decision making. So would you like to add to that?
Yes, I believe one critical aspect of all this data is that you don't want to lose precious data, and you don't want to replicate things and lose value along the way. So what's important is that we all work on a common base of information, and we are able to have interoperable solutions by cities and share best practices. Or if something is working in a city, it could be duplicated in another city. If something is working with a company, another company can build on top of this. And for that, we need common denominators. We need common infrastructure. And I believe digital twins for cities are the perfect example of how we can share data in a common environment. Every building now has a digital copy. If you look on Google Earth or on any map, you see buildings in 3D. We should use that as a base to build on top of and to share information within cities. So we have an initiative with the city of Miami that we call the Miamiverse, which is an interoperable digital twin of downtown Miami, and it's a sandbox for any building to join and connect first to public data for the public APIs for traffic, air transportation, pollution, and also share private data from the building that will help service provider act in the building, that will help tenants also share data from the building. And once you have that base, all these data can connect to one another, and then you start adding value, and you can share that information with other cities and grow exponentially. So I think the base for sharing data should be a common digital twin by starting with a district. Take a district, and you have hundreds of buildings, and those buildings start communicating data to one another. And we build on top of that, and we grow, district by district, city by city. So we see.
Yeah. Tony, so given that we reached that point that we have all this, wealth of data, we can have all this information in real time, how do you think we can use that for developing more sustainable living?
Sure. Well, first I would say we have a lot of data, but we don't have all the right data points. And I think we've talked about that a little bit. So the near miss analysis, or even the economic ROI for great streets. That information still isn't out there. It's not easily collected. And a lot of the work that we do is still piecemeal. So for our projects, for example, when we're doing a test of something or building a street, we're not able to in real time, 365, collect data all the time. So you don't really have that yet for the type of work that we do. I can see that coming, and we're starting to be able to apply it. We'll have to, for example, if we're doing one project, put up one camera or a couple of cameras at intersections to get some data. So the information that we're getting is incomplete. So we can only make decisions based on that information, but it's getting there. I see some light at the end of the tunnel when it comes to that. I think we're still a little bit a ways from being able to use that data in a meaningful way. But otherwise, there are platforms out there like Placer. I don't know if you've all heard of Placer. Placer is a platform that collects cell phone data for origin and destinations for public spaces and transportation. Now, that's great if we're trying to make a case for the success or use of a public space or the design of a public space. These layers exist all in independent places, and they don't talk to each other necessarily, and it's very difficult for practitioners to actually use that and to seek out those firms. So I think there's still a challenge there for us when it comes to using the technology in the right way. And then Victor alluded to this also, it's outcomes based. Like you see that in the data, whatever you want to see. So the highway engineers are going to see we need more highways. The humanist urban planners are going to see we need better streets for people walking and biking. So the data is not going to be able to solve for that part of it either. You still need people like us who are interpreting that, I think. And maybe the AI people here will tell me that I'm wrong. We'll design a computer that will interpret like a digital, the digital version of Victor and Tony will take over our jobs.
Yeah, and one more challenge is, we get to that point, we know what needs to be done. We want to change the city, but it's not easy. It's not from one day to another. We have a lot of conversations with the government to make that happen and with the city. So, Victor, I'd like you to expand a little bit on that, especially when we are retrofitting a city, changing it dramatically. Do you have examples you'd like to share with us and how we could do that?
I kind of hoped this would come up, and because I just got a video clip. I wonder if the AV guys could run that. I just got a video clip from Paris. So if you haven't been following the story that flows from the 15-minute city concept that Professor Costa touched on in his talk, Paris has been undergoing very rapid change. They've implemented hundreds of kilometers of protected bikeways, reduced the amount of space in the city devoted to moving and storing automobiles. Basically at the beginning of Mayor Hidalgo's second term to the present, streets like the Rue de Rivoli and as seen there were once just jammed with cars from end to end, barely moving at all times. Now they're filled with, in fact, are you counting? How many modes of transportation are you seeing in this video clip? The same spaces, you called it redesign. I think this might be what you were getting at, is we constantly retrofit cities. Cities are works in progress, never finished. And so the missing piece to this values clarification challenge that Tony dropped, and your question, might be the power of political leadership. It's and Anthony mentioned this a little while ago. I don't think we can choose between just top-down and bottom-up solutions. We need both things operating in both directions, and often the call for reform will come from the bottom, and the implementation will come from leadership. Taking risks and saying, let's test this through rapid prototyping, for example. And anyway, the result in Paris is really remarkable. They just had a referendum in which the citizens there voted to do a lot more of it, 500 more streets, in which they rebalanced the relationship between cars and all the other things, all the other modes of travel. And I think that if I use the Paris example for one last reason, it's also beautiful. We tend, because we all grow up in science, we tend to think that it's just the math or even just the data that you can show the mayor will have return on investment or across administrations. I picked up on that. We also need to figure that the city's job is to communicate what its society values and to present itself in a competitive way, a brand loyal way. And that means it has to be beautiful. It has to inspire people. It can't just work a little better or make a little more money or save a little money. It's actually got to reach people in their soul. And what will that do? That will make us want to retrofit it again in another generation to keep it viable and workable and make it more valuable, not less, with change over time. So that phrase hasn't come up a lot today, but I think change over time might be a common thread in everything I heard this afternoon. A sudden change, gradual change informed by information instead of just guessing. It's all about that. So that's probably the missing piece. Interoperability between the data sets, it's not there. We find that it's getting better and better. I think Tony's right about that. I am amazed at how much faster we can get a decision from a client because we can share our screen and they can look at the same Google Earth Street View image that we're looking at. And it's easy to forget. That's recent. That's recent technology. We didn't have that before. We were designing cities by floating hot air balloons and looking down, taking photographs and hoping for the best. And now we have an amazing amount of information available and no excuse for anything but the best cities yet.
So, Fredrik, then coming to ask you, going to the individual level, as he said, like we also want to consider what people want, what they are, their desires for the city. How does, what you do, like prototyping and 3D, construction, how does it work? How it can support to hear the voices of these individual needs, and bring it back up to the development of the city?
Okay, so let's see how I can bridge that. I can. What you just mentioned here is interesting with how you direct can do modifications, because with new technology you can do direct customization very quick. So we see that both in the coastal infrastructure but also housing. We can sit with an engineering firm and we can see the place where it's going. We can see the depth of the water that we need to protect, and we can build the model of the unit and lay it out as we speak. That's very shocking for engineering firms, and this also goes for housing. So when you're working with digital construction or 3D concrete printing, you are not limited like you are with regular construction. You have blocks and you put them in a certain way. It costs the same with a 3D printer to do a curved wall or a curved room or 4 rooms as it makes with 3 rooms. So we can very quick, and that's maybe within, single family housing or multifamily and so on. We can quickly adjust the floor plan. It's not only easy in the design and the architecture or an office building, but we can really load it into our printer and print customized project and housing and so on. So the digital constructions, especially construction 3D printing, is really revolutionizing how you can build in cities, and that goes for any type of projects. And we have 2 ways of manufacturing. So one is we have a machine from a company named Kohl, which is based on a gantry system that is parked in our warehouse in Pompano Beach, where we do infrastructure. We're printing inside. But we're also working with 2 or 3 now different machines that is on-site printing, so we can bring out the machine out to the site. That is mounted on the back of a trailer or a boom truck with the technology. So different kind of machines open up for different kind of customization and different kind of new ways of building different products.
Thank you. Thank you. So now I would like to, open for questions from the audience. We have a few more minutes before we finish the panel. So, yes?
Thank you very much. I have 2 questions to the public sector technology of NVIDIA. Thank you very much. What are the NVIDIA's concrete 1 or 2 projects, AI applications you are working on developing or supporting to address pressing issues in pressing social issues such as healthcare, education, or environmental sustainability? And the second question is what quantum computing developments or technologies you are working on in partnership with public sectors such as healthcare or education or environment using quantum computing? Thank you.
Thank you. She asked amazing questions, by the way. But so I think the first question was, what are some of the issues of dealing with oppression as well as sustainability? One of the biggest things that we're doing that we're really excited about right now is Earth 2, a company called Tomorrow.ai that NVIDIA has partnered with, where you're starting to look at the possibilities of revolutionizing, the work that the National Weather Service does in real time. So being able to kind of model predictively some of the outcomes of wind and land movement and things like that in real time, and then handing that down to decision makers, local government leaders, state leaders, federal agencies to try to start getting ahead of things as preparations for extreme weather events. So weather intelligence has replaced the word climate change. And so just looking at it from that perspective to see how we can be more intelligent, more agile in real time. That's a really big one. With regards to oppression, there's not really anything NVIDIA specifically I can say is doing, but there are things that we are helping our customers do, just with their data, with our AI models, as well as all of the other, large language model providers and artificial intelligence companies, just looking at how you're using the data and how you're turning that data into wisdom and maybe enhancing the capabilities of your human decision makers that are tasked with trying to analyze very large amounts of data, years and years and years of data, and make intelligent decisions about it. With regards to quantum, we're doing a lot in the quantum space. Quantum feels early now for the public sector right now, but the developments are rapidly emerging. I'll save some of that a little bit for a deeper discussion, because there's not really anything right now tangible that I can say is being done as an example or a use case with quantum. But all I can say is that quantum is very near, and quantum is going to be landscape changing once a few key things are figured out. Is that a good answer? All right.
More questions from the audience?
Hi. Oh, hi. I was wondering if I could hear more from Mr. Merchado about the Miamiverse initiative. Yes. Just like what kind of industries have gotten involved so far, and what data you're mapping in the Miamiverse, other than just trying to get 3D scans of the buildings, and if you're doing any sort of like predictive mapping, that sort of thing.
Right. So, hello. Yeah. Yes. So yes, the idea of the Miamiverse is to have a comprehensive map of Miami that can be shared with anyone, and we want to create a sandbox, as I said, with different type of buildings, being commercial building, residential, mixed use, logistics, and each of these use case will show us the benefits of adding these technologies together and how you can optimize energy consumption. In a commercial building, for example, is different than in a residential building. It's also different from a logistic building. So we want to have as many buildings as possible to show the benefits. And then once we have clear ROIs, we can justify for the deployment of these technologies. For instance, right now, the best use case for these technologies is energy performance. We know that the cost of the sensors and the creation of the digital twin can be offset after 1.5 years. So you have ROI on energy performance that offset the cost. Now you can use this for predictive maintenance to avoid some equipment to fail, and before they fail and you experiment downtime, you can act upon it beforehand and you save money on your operational management. So we know where are those value pockets that we can save money on, but we don't have enough experience to have some backtesting on it, so we can deploy. So the idea with the Miamiverse is to have use cases in a sandbox environment, working with we are, by the way, we are endorsed by Miami-Dade County, by Mayor Levin Cava. It's officially a project endorsed by the county. And the idea is to share this information to other buildings so we can deploy more and more and more of these. We believe that the combination of the digital twins, blockchain, and AI will create a paradigm shift in the way we manage buildings, because those digital twins, they were used originally for design and construction. We take them for the operational management. And so now, the same way a building has a physical address where you can find the information, now it has a unique digital address that will follow all the life cycle. And once you have that, you avoid a lot of expenses that are very costly. When, let's say, you are losing a service provider in a building, for example, you have to recollect the data again and again. You lose your electrician, you have to open the walls practically. You lose your property manager, you lose all the data. So the handover of the data from one owner or one service provider to the other is super costly to all the stakeholders of the building, not only the owner, but also the service provider and so on. So we believe that this value that is lost, that we gain, we can redistribute it. So it's lowering the rents, improving the margins of the service providers, and so on. So all this value lost, we can redistribute it. So that's the idea of the sandbox in the Miamiverse.
Thank you. So we have time for one more question. Who would like to ask a question, please?
Thank you. Can you hear me? So many have talked about prioritizing humans and prioritizing tech efficiency, but what about prioritizing the environment or ecosystem which we all are participating in and living in? I work in natural spaces, so those things are a little bit hard to quantify, but there's many things contained within them that might be valuable, but don't have as much of a clear monetary value.
Well, I think indirectly, the work that Victor and I do is all about the proposition of having people live compactly and saving natural areas and really thinking about how we use our land efficiently. So maybe not indirectly, in a very direct way, the work that we're doing and how we're using technology is all about returning to a more compact pattern so that we're living closer together and using less land. Fundamentally, I think that is the most sort of ecologically minded and environmentally minded position. I mean, there are a bunch of other ways, I'm sure, that others can speak to, like tracking urban forestry and conservation areas in cities and that sort of thing. But at least just from the built environment, living more compactly and using this technology is environmental.
Also using maybe also sensors to collect information about the air quality in buildings. Some buildings have mold that can affect your health, or the water quality. Also in the built environment, you have a lot of materials that are used for the construction, and monitoring how they are used and how they are recycled is also helping the environment. So it's all about collecting data and acting upon it. So we have to build a circular loop between the stakeholders of cities to assess a situation over and over and over again, and act upon it and make decisions collectively. So it's very important that at this point of time we all come together, because that's when people start working together that cities thrive, and that's really the goal of all these technologies, to work for the benefit of all. So we all need to assess that and act upon it.
I love this question, and I think you said it was the last one, and I'm really happy that we're ending on this subject, because it's really key. We've been talking about designing and planning, and what those really are processes of testing scenarios, asking ourselves, what if this? What if we draw the line that way? What if we run the main street that way instead of that way? What if we spread things out or bring things together, to Tony's compactness point? So you're testing those hypotheses. Here's option A, here's option B. Let's see which one works better. The data and analysis can help us with predictive comparisons and making better choices. And in the past, we've had to just say, well, it's obvious that A is better than B because best practices. Here's the list of the published best practices or something. But now we can actually say, no, A is better than B because here's how much energy it will save, here's how much emissions it will help avoid, or here's how many trips we can shorten for the transportation topic, for example. We can do the same thing with water quality, and I think that's pretty powerful to think about. Think of it. Our ability to test hypotheses about which plan we should follow and which one will have the best ecological outcomes in particular, we are much better able to do that now than we were in the distant past. I think there were some good habits that humans had about planning human settlements that they got in the habit of, for example, interconnecting street systems and building compactly and building on the high ground, not in the flood-prone land and things like that. And we kind of destroyed those habits. The question earlier from our Fulbright scholar was, how do we get stuck with all of this driving kids everywhere instead of letting the kids walk themselves or bike themselves to school or use public transit as they do in her home country? That question earlier today was also she was mystified by why we would deliberately build our built environment this way. The answer is bad habits, and the bad habits get reinforced through feedback loops that are hard to break unless you have new information. And so now we really do have the ability to make a chart. Here's how much energy it will save. Here's how much recidivism will go down. Here's how many fewer school kids will end up in the classroom to prison pipeline. Here's how much better the water quality will be. And I'll just give you one really, really simple GIS example. We couldn't do this before, but now we can. One of our professors here, who has a dual appointment in the School of Architecture and the School of Medicine, did a study of 250,000 Medicare recipients in Miami-Dade. And they balanced all of the participants in the study for factors like their household income, their ethnicity, cultural backgrounds, physical locations. And then they simply compared greenness. How much tree canopy is on and around the block where their address is located in the GIS? And guess what? If they were in a place with a higher degree of greenness, lots of public health outcomes were improved. Ones you might expect, like less heart disease, less high blood pressure, because having trees and green was a factor in people's cardiovascular health. and better air quality. But there were some other things like lower incidence of early onset diabetes and lower incidence of Alzheimer's symptoms and on and on and on. They went down this and found enormous correlations between greenness and public health outcomes. And the only way to do that was with the computer technology and data that we have now. It would have been impossible to run that study prior to the accumulation of this data. So I think in public health or environmental health, we have tools we didn't have before, and we have no excuse. We should be using them.
Thank you, Victor. So thank you so much for your the lively discussion, and I hope you keep discussing with the audience. Thank you so much also for the questions, and now we move for the next presentation. Thank you.